Welcome to section 7.1, radical expressions and graphs. All right, so we have something, the radical expression, and we're going to look at what the meaning of the nth root of a. We read that nth root of a. What does it mean? Well, the nth root of a equal to some number means that b to the nth power equals a. So let's take a look at this again. The nth root becomes the power of b, and the item inside the root is the answer to b raised to that n power. So for example, the square root of 100 equals what? Well, what times itself gives me 100? 10, right? This is saying the same thing as 10 squared equals 100. To the nth root, when I square it, I get the item on the inside. Okay, so we have a few different cases we're looking at. So if n is even, and a is positive or 0, so the item inside is positive or 0, then the nth root of a represents the principal nth root of a, which is the positive, and a negative nth root of a is once again the positive root. And case 2, if n is even, and a is negative, so the item inside is a negative number, then what do we know? Then the nth root of a is not real. This is important, remember this one. For example, if I had the square root of negative 4, there is no number that when I multiply it to itself gives me negative 4. Negative 2 times negative 2 would give me positive 4. And 2 times 2 would also give me positive 4. It does not exist if you have a negative number on the inside, which is why we would say it's not real. And case 3. If n is odd. For example, maybe a cube root of n, cube root of a. So if n is odd, what do we know? Then there is one real root of a. Okay, so basically it's talking about if our n value, let me go ahead and see this, if this is even or odd, that will affect that depending on if it's positive or negative. So you got to keep a lookout for that. Make sure if you're just note whether this is even or odd, and note whether this is positive or negative. That will change the kind of answer you get. So let's take a look at example 1. Find each root. And what does a root mean? Basically, you're just simplifying it. So the square root of 100 over 49. Well, I can simplify this using rules of roots, which I can simplify to root 100 over root 49. And root 100 is just asking me what times itself gives me 100. Well, we know that's 10 times 10. So the root of 100 is 10. Now root 49 is saying what times itself twice gives me 49. And I know that that is 7. So my answer is 10 over 7. Now let's take a look at the next one. This is the fourth root of 16. So this is saying what times itself 4 times gives me 16. It has to be the same number and the same sign. So that would be 2 times 2 times 2 times 2. Because 2 times 2 is 4. And then 4 times 4 is 16. So the fourth root of 16 is 2. And let's take a look at the next one. We want the fourth root of negative 16. So once again, we're trying to see if we can add a number to itself 4 times to get negative 16. Well, I know that 2 times 2 times 2 times 2 gave me a positive 16. What if I tried negative 2 times negative 2? That's the only other option I have. Well, negative 2 times negative 2 is 4. That's also 4. oh darn, that's a positive 16. I can't find a way to get a negative 16. It's not possible to get a negative 16. Which is this rule here. If n is even, which it was even, and a is negative, 16 was negative, then what do we know? It's not a real number. So my answer for this is going to be 4th root of negative 16 is not a real number. Kind of interesting. Now let's take a look at the next one. Negative 4th root of 16. Well, we already know that the 4th root of 16 is 2, right? So this is going to be the opposite of 2, which is just negative 2. So the negative on the outside didn't change our answer. How about the next one? The cube root of negative 8. This is saying what times itself 3 times would give me negative 8. Well, negative 2 times negative 2 times negative 2 could be a good bet. Negative 2 times negative 2 is 4. And then 4 times, I'll bring down that negative 2, is the negative 8. So that works. The cube root of negative 3 is, the cube root of negative 8 is negative 2. Which works with that rule that we learned right here. If the n is odd, we had a cube root, then there's one real root, which we found. Now let's take a look at f. Once again, we're looking at a cube root. We want to know, well, you know what? I can actually split this cube root. That's a cube root of 8 over the cube root of 27. So now we're looking at what times itself 3 times gives me 8, and then what times itself 3 times gives me 27. Well, I already know that 2 times 2 times 2 gives me 8. So this is going to be 2 over what? Well, let's try 1 up. 3, 3, 3. 3 times 3 is 9. 9 times, bring down that 3, is 27. And it's the right sign. So that's going to be 2 over 3. All right, let's move along. What is the meaning of nth root of a to the n? And this is on page 459 of your textbook. Once again, make sure to read your textbook, especially look at the definitions. So what do we know? Well, there's 2 options. When n is even, what do we get? The nth root of a to the n. They're going to, in a sense, cancel each other, and we're left with the absolute value of a. We have to be careful, we need the absolute value. And the next one, when n is an odd positive integer, what do you know? Well, the nth root of a to the n is just going to end up equaling a. We don't have to worry about the absolute values. Usually, however, you'll notice a lot of times with the variables in Math 103 or Math 82, it'll tell you we're working with a positive integer, which means you wouldn't have to worry about the absolute values. However, if they don't tell you if your variable is positive, then you need to worry about the absolute values. All right, let's take a look at example 2. Simplify each root. Oh, let's see. Well, we have the 6th root of negative 3 to the 6th. Which one does this match? This matches the first case, because n is even. 1, 2, even. So the answer is going to be the absolute value of what's on the inside. So that'll be the absolute value of negative 3, which is just going to be 3. Interesting. So they cancel themselves out, and we're left with 3. Now the next one. Ooh, same thing happens, because we still have that even integer, 4 and 4. However, we have to be careful. We got that negative hanging out right there. So we have to remember to bring in that negative. And then we have negative and the absolute value of negative 10. Still keep that negative. Well, the absolute value of negative 10 is just 10. But we still had that negative on the outside, so it's going to end up being negative 10. A lot of negatives flying around, so be careful. And then the last one. Cube root of x to the 18. That doesn't match either of the ones here, because the exponent is not matching the index number. It's the index and that's the exponent. But I can manipulate this problem, and a lot of math is manipulating things to look a certain way. I can manipulate this. Let's see, that's going to be what to the 3rd power. I'm trying to match these two, okay? So that's what I'm doing. I wanted these both to be 3 because then I can use this property here. So my question is, I'm going to use the power rule. 3 times what gives me 18? Well, 3 times 6 gives me 18. So I'm going to rewrite x to the 18th as x to the 6 times 3, or raised to the third power. Because remember, that's the power to power rule, that is 6 times 3, which will once again give me the 18. So I'll rewrite this x to the 6th power. And now I can use that cancellation rule. But since it was an odd positive integer, they just cancel, and I'm just left with x to the 6th. I don't need to worry about the absolute values. Alright, that is it for this section. That was a rather short section. Once again, if you need help with any of these problems, please stop by an office hour or email me. We can set up a time to meet.